Hello NSA student, this is a question that I get a lot and it's related to the volumes and the areas and the similarity ratios of similar figures. So this says the volumes of two similar solids are 729 meters cubed and 125 meters cubed. The rest of the question, which is cut off here because of the way it's oriented, says that the surface area of the larger solid, so let me just write this in here, the surface area of the larger solid is equal to 324 meters squared. And then the question is, what is the surface area of the smaller? Okay, so what we're looking for is the surface area of the smaller solid. Now, they don't tell us what type of solid this is. It could be a sphere, it could be a pyramid. They don't tell us anything about that. And we don't need to know that information because we know the similarity ratio, or rather we can find the similarity ratio of these two things. If we're given the volume of two similar solids, to find the similarity ratio, we use the cube roots, okay? Because a volume is a cubic function. It's a three-dimensional quantity. Length times width times height, for example. So there's cubic units involved. So to find the similarity ratio of the original shape, we use the cube roots. So the similarity ratio is going to be the cube root of 729 divided by the cube root of 125, and that's equal to 9 over 5. Sorry, these are cube roots. The cube root of 729 is 9, the cube root of 125 is 5. So that is the similarity ratio of these two figures. Okay, now we're given the surface area of the large, and what we're looking for is the surface area of the small. Now, just like the similarity ratio is the cube root of the volumes, the similarity ratio is going to be the square root of the areas, okay, because an area is a two-dimensional quantity. So the similarity of the areas is going to be the square of these two things. So 9 squared is 81. 5 squared is 25, and this is going to be related to the areas. Okay, we started with volumes. Okay, here we had the volumes, and we used the cube root of those to find the ratio of the two figures, and then we'll square that value to find the ratio of the areas. So the ratio of the areas of these two figures is 81 to 25. Now I can use that to set up a proportion. The area, or the surface area of the larger figure, which is on top here, is 324. And what I'm looking for is the surface area of the smaller figure. And from here we can cross multiply. 81 times x equals 324 times 25 is equal to 8100. And then we have an easy problem to solve there. X is 8100 divided by 81, which is 100 meters squared. That's how these problems work. So you have to remember those three facts. The ratio of the solid, to go from the similarity ratio to the area, you square it. And to go from the similarity ratio to the volume, you cube it. And then so to work backwards, you use cube roots and square roots. But this is how these types of problems will always work. Thanks, and have a great day.